Hi, this is Lucintel. Today we're going to be talking with Bobby Perkins from DGS, and today we're specifically talking about their new system, which is
spectrum management. So DGS, Digital Global Systems, started in 2013 with over 230 patents in AI-enabled spectrum management and optimization. Here today we have the DGS 8280 receiver. And when you think about wireless, you have to think of situational awareness, command and control. We have thousands of different types of frequencies and channels operating in a congested environment. And the challenge with that is it's congested.
Yeah. So what exactly is spectrum management in simple words, kind of?
So when you think of spectrum management, think of a referee, think of a police officer. You think of a referee on a baseball or football game, they're managing the game. They're not dictating the game, but they're managing the game when the problems occur. With the spectrum, you're also going to have the same problem, right? There's congestion, there's interference, there's noise. And so as a referee or as a police officer, you want to be able to manage that spectrum to make sure those channels are being utilized and the spectrum is being optimized all at the same time in an efficient manner, not only again, there's different use cases, but also not just for the end user itself, but also for the enterprise.
Yeah, and so you kind of touched on a bit, like what is the real true importance of having someone make sure managing the spectrum itself? What's the importance of this? Because a lot of right now, it's a big buzz to do private networks and 5G, and so how necessary is this and why?
So with our platform, it's extremely necessary. You're looking at public safety. You're looking at the hospitality industry, the ports, Department of Defense. You have different types of radios that are involved, right? And so the challenge there is when you have these different frequencies and these different channels operating at simultaneously, you run the risk of failure. And the challenge with that also is you want to have those applications ready for any mission critical situations. In the public safety realm, you have video surveillance, you have drone detection. These are opportunities where not only from a public safety standpoint where you can optimize that network to look at different types of video, but also at the same time being able to do that drone detection and say, you know what, there's a serious threat over here or in this area for public safety.
And can you kind of explain how the monitoring works? Is it using AI or is it done specifically with a human?
Sure. So AI is not just a buzzword here at DGS, it's also the reality. We have over, again, 230 patents that are all AI enabled that started in 2013. And what that allows you to do, it allows you to provide that true edge compute, but also that real-time situational awareness to be able to look at different types of spectrum, the associated protocols, and be able to gather that information to be able to make a better decision for whatever the operating area is. Or in the public safety in the DoD realm, you're also looking at different types of surveillance, different types of threats. In the commercial realm, you're looking at, for example, stadiums where there's hundreds of thousands of people that could be in a given location, and you want to make sure they're safe, right? And that they're using the network for what it's being used for, and not for any type of malicious intent.
Yeah, and you mentioned DoD, and so I was wondering kind of more of the defense applications of this. So you were saying how on a network, I know you guys have the propagation system, so you can see how strong the network is throughout different areas, but are you also able to detect who is using the network at the time and what amount of power they're using, kind of what they're doing with that?
Sure. So going back to what I was saying before around different protocols for different frequencies, it's a challenge, right? But every single frequency has its own separate channels and protocols. And in the DoD space, there's also the agencies. So part of this also too is identifying different types of RF signatures. In a network or in a cellular network, a cellular coverage area in the DoD, we'll say a flight line or perimeter security, you already know that your spectrum is being utilized for that specific thing. We'll just say surveillance. The moment that you see a different type of RF signature, whether it's a drone, whether it's another device, it could be an entirely different network, that could be a problem because that network is not supposed to be within that cell area. Yeah. And so to be able to identify it, interrogate it, and also potentially gather that mission critical intelligence data from that specific device or the group of devices is crucial to the Department of Defense when we look at national security.
Yeah. And what kind of other customers would you mainly see using your system like this?
Great question. So when you look at not just the public safety standpoint, you're also looking at the port authorities. Ships are coming in and out of the different ports. The Carnival Cruise Lines, the cruise line industry, NCL, Disney Cruise Lines. These ships are operating on their own spectrum as well, right? So there's a lot of congestion. So you look at the port authorities. Then you look at the hospitality industry where there's different types of resorts everywhere. We know the big names, the Marriotts, the Hiltons, etc. But the challenge with that is we go to these resorts to vacation, but there's also other operations going on.
Yeah.
It's a hospitality industry, so the restaurants have their POS systems. We do not want those POS systems to go down, right? Because that means dollars are being lost. But if dollars are being lost because of we didn't know that RF was being interfered with, that's a problem, right? So look into sports and entertainment, the same thing. Those POS systems and the merchant services devices that are at these entertainment at the stadiums and arenas, they have to work. A couple of years ago, or even last year, there was an incident where over 1,000 POS devices at a stadium went down. And it was because of RF interference. That translates into dollars and cents, and really it can be billions of dollars being lost in a given time or over a given time over the years.
So how does your product, for example, you said when a POS system goes down, how do you guys work against that? So clearly you're monitoring, so you know when it happens, but what are the further steps that are taken to kind of make sure that doesn't happen?
Sure. One of the first things is to understand where the access points are currently deployed within that given area, the number of access points, what is the cell zone that they're actually, what's the coverage area, the APLE placement, and then once you look at where that RF propagation is within that given area, now we can, as DGS, we can go in and say, you know what, we need sensors here, here, and here to optimize your network so that way we can do predictive analysis. We can also do real-time interrogation of other networks that could interfere with those POS systems. And also we're looking at that specific spectrum usage for that POS system or systems.
Yeah, okay. And what would you say right now are kind of some of the biggest cybersecurity threats we're seeing, or things with like leakages? What are kind of ways to, first of all, the biggest issues with that, and also ways to deter from that?
I say one of the biggest challenges within RF is overpropagation of RF. We say, well, we have this coverage area, but we want more customers to be engaged in this activity. We need to have more customers on the network or end user devices, so we'll amp up the power. That's not always the solution. Sometimes you may have to bring the power down and provide more access points. But the challenge, even with that scenario, you still want to be able to interrogate your network from an RF perspective and make sure that that spectrum is being maximized and utilized efficiently within those channel allocations. You do not want to just overpower a network and create more noise on the network. And what that'll do too is it can also bring your entire network down as well. So from that perspective, making sure that you have the right channel allocation, you're also the right devices, whitelisting your network, providing a cybersecurity zero trust architecture is also part of it. But also when it comes to network spectrum service enabled awareness, is being able to optimize the network from a channel and protocol standpoint. So each spectrum has its own set of protocols. So when you can whitelist your spectrum, you can also whitelist your protocols, which then you can whitelist your SIMs or your eSIMs, and then your devices. So now you've basically created a very more secure network within not only within your spectrum, but also within your 5G space.
Okay, and I think these are pretty important topics for people to know about, because a lot of times you just kind of implement the first step, you're not sure all these other things that are necessary. So I think this is great that you were able to discuss this. And you mentioned the whitelisting. Can you explain that a little bit more?
Yeah, traditional whitelisting is between MAC addresses and SIM cards and IMEIs. But again, when you look at, you peel back the onion, every frequency and channel has its own set of protocols and security posture. So within the 5G space and private 5G space, there's new ciphers. So what you can wind up doing is provide a level of not only cipher security, but also protocol security on the actual frequency to not only pull that data from out of the air to identify who that interferer could be, but also as you're looking at the network from, is that device working properly? Is that device really active? Instead of just sitting on the network, is it actually pulling data and being an active attendant, if you will, on the network? We have that capability. The one other part that I was going to mention too, how to combat, some of the challenges as far as not just the interferers or interrogators that are out there on the network, but also probably the biggest challenge is oversaturation and congestion. So when we can see through this network, through our platform, the level of congestion from frequencies, capacity management, data usage, we can identify those characteristics and a lot more to be able to tell that provider or that specific customer, this is how we would want to help you and maximize your infrastructure so that it can not only be resilient, but that end user can be able to access those mission critical applications.
Yeah.
Thank you so much for watching. Check out the link below to read the full article on this topic and to see others like it, and to also gain access to our website where you can see our further capabilities in consulting and market research.